Alrighty, we are looking at lesson 8.2. The previous video was a pre-lesson for this because I started recording it and I realized that I just really wanted to make sure that we had that pre-lesson in hand. So make sure you're okay with that stuff. Maybe rewatch that if you need to super quick. But yeah, we're getting into it. By the way, for people that have not done that Alex quiz yet, if you're in my class as we're running this right now, questions 4 and 5 are from this lesson. So if you already had that done, don't worry about trying to retake it. You're set. If you have not done that yet, then just make sure you're trying your best on 4 and 5 after watching through this video, because then you'll actually be able to do it. I'm sorry that I assigned that before this. Okay, let's jump to it. So the objective for today is to be able to factor and solve quadratics using the greatest common factors by analyzing examples. And, this is not our situation right now. I should probably start changing the language CLOs, but it's fine. So for the do now, it's just asking us to find the greatest common factors for the following values, 16 and 30, and then 45 and 72. So try that out. Make your best guess. Maybe grab a calculator and start getting the list of factors. But yeah. So what I've got over here is I already have the questions solved, just because I also earlier this morning tried a recording of this video and it was taking way too long. So I just here it is. So I have the list of factors for 16 and 30 over here. It's all the numbers that would multiply together to make 16, all the numbers that would multiply together to make 30. And what we've got is, once I have all the list of factors, to find the GCF, the greatest common factor, is you just compare the two sets of factors, the two lists of factors, and you figure out which one of them in common, which number in common between here is the greatest. So I see that, oh man, this is lagging real bad, sorry. I see that the biggest number that both of these share is 2 and then 2. And similarly, I create the list of factors. I'll let that camera catch up. I create the list of factors for 45 and 72, and I find that the greatest number that both of them share together in their list of factors is 9. So the GCF between these two is 9. What we're learning today is basically how to do that, but instead of just between two numbers, using a full expression, and you might have variables and exponents and all that good stuff. So let's get to it. Factoring out a greatest common factor is like doing the distributive property in reverse, and this is always the first method of factoring that you should be checking for. And so let's just kind of think about that for a second. Back to the do now, which was, okay, when I'm finding the GCF, really what I'm doing is finding the biggest number that I'm able to divide out of both of these, right? 45 can be cleanly divided by 1 and 45, 3 and 15, or 5 and 9, and 72 with all of these. And what I'm doing when I find the GCF is it's the biggest number that I'm able to divide out of 45 cleanly, and the biggest number that I'm able to divide out of 72 cleanly. Yes, I know that, hold on, let me rephrase that. I know the biggest number for 45 is 45, and the biggest number for 72 is 72. But the biggest number that both of these lists have is 9, and that's why it's called the greatest common factor. So we're going to be looking at that today. Oh, and the reason I even switched to that was, it says this is the distributive property in reverse. Well, it's like saying I can divide a 9 out of 45 and 72. And distributing is just multiplying something into a set of parentheses. So the reverse is like dividing something out of an expression, right? And that's exactly what we were doing when we found the GCF. It's what's the biggest number that I can divide out of both of them. Here are two examples. I'm not going to go over them, but just take a look at these two examples over here. 3x plus 9, when I factor it, it's going to become 3 parentheses x plus 3. And you can see if I start with this, we're doing the opposite of distribution. I end up with this. And so when I have my solution here, if I would distribute this back in, I should get back to where I started. That's how we're going to be able to check ourselves. And if you look, 3 times x, 3 times 3 would get me 3x plus 9. Similarly here, we have a 5a squared minus 10a. When we do the factoring, which we'll be learning in this video, you end up with 5a parentheses a minus 2. And if I did the distribution here, once I have done the factoring, 5a times a would get me 5a squared. 5a times negative 2, 5 times negative 2 is negative 10. The a just comes along for the ride. You're good. So that is where we want to get to. And you're just seeing how I'm going to start with something like this and end up with something like that. And distribution is how we check it. But what we're trying to learn today is we know how to do distribution. We're going from the left side here to the right side there. Okay, so let's get to example number 1, where we're looking at how to find the GCF for variables. In the do now, we saw the GCF for numbers. GCF for variables is really not that crazy. And I'm going to get another piece of paper up over here, and we're going to look at a cubed, b squared, and a squared, b cubed. Okay. So here we are. When you're finding the GCF, with numbers, you have to list out all the factors. You're looking for the biggest number that matches in both of those lists, right? Like we had from the do now. For variables, it's sometimes confusing for students at the start, but it's actually a lot easier than finding the GCF for numbers. What you're looking for when you're looking for the GCF between two terms that have variables in them is you're looking for what am I able to divide out from both of these terms such that they can both afford it, right? What's the biggest amount of a letter that both of these guys can have taken away from them? So here I have an a to the power of 3. In this term, I have an a to the power of 2. You got to do it variable by variable, one letter at a time. So this left guy has 3 a's multiplying by each other. So really, this could expand out to a. This guy on the right has 2 a's multiplying times themselves. So the most that I'm allowed to take from each of these terms would be, this guy could afford up to 3. This guy can only afford an a squared, only 2 a's multiplying times itself. So I'm going to divide out an a squared from each of these because I need to take out the most that I can from both. So I'm going to take out an a squared from both of these guys. Bring in this a squared over here. And then similarly, I got to look at the b's. Now this guy can only afford a b squared. This guy can afford b to the power of 3, so the most that I'm able to take out is a b squared. So we're going to drag that out over here. So this guy, we're taking out a b squared, and this guy, we're dragging out a b squared. And now all you got to do is just look at each term and say, okay, I divided out an a squared from each of these and a b squared from each of these. So I'm going to do it from this term first. A cubed over b squared, divide out a squared, b squared. Oh, am I getting ahead of myself? Yeah, never. I don't even want to go this far. All we're just looking at is this is what I'm able to take out from both of them. That is the GCF. So we come back to the thing over here. The GCF is there's an a cubed and an a squared, so the most I can take out of here is a squared. Oh man, I got to put this into, I don't want to make it look ugly. Let's make it an equation. The GCF that I can take out is an a squared. Come on, you got this. And a b squared. Because this has a to the power of 3 and a squared, so the most I can take out from both of these is an a squared. B squared, b cubed. The most I can take out from both of them is a b squared. And so what you're really looking for is when you're looking for the GCF of variables, you can... so let me say this a little better. The GCF for variables is the lowest exponent available, right? It's the lowest exponent available. It's the lowest exponent between both of them. So the lowest exponent for the a's, a cubed and a squared, was the a squared, so we take the a squared out. The lowest exponent between the b's in these two terms was a b squared, so we take the b squared out. Let's keep going. All right, so now we're going to put the numbers and the variables together. If I'm looking at a 5a squared and a 10a cubed, first we want to find the GCF of the coefficients. So the greatest common factor between a 5 and a 10, 5 can only be divided by 1 and 5, and the 10 can be divided by 1 and 10, 2 and 5. So the greatest common factor I can get from both of those is a 5. The greatest common variable with this, or sorry, what is the common variable with the smallest exponent? So they both have an a. This is an a squared and an a cubed. The smallest exponent is the a squared. So what I'm going to have to take out here, the GCF there is going to be, let's get to, man, I wish I knew the hotkey for this. I'll have to look it up after this video. Is going to be, whoops, an a, oh man, is going to be an a squared because it's the common variable with the smallest exponent, a squared, that's it. And then to get the total GCF, you just put them together. 5a squared. So what I'm going to get is 5a squared. And we'll write it with the equation over here, 5a, whoops, squared. Let's keep going. I feel like this video is already running on, so I want to start moving here. They're asking to find the GCF between 12x squared and 15x cubed. The GCF for the coefficients, let's do that really quick. So 12x squared, 15x cubed. I'm going to just jump to the paper over here. So 12, I know can be divided into 1 and 12, 2 and 6, 3 and 4. I'd get to 4 again. I'm done with my factors for 12. A 15 can be divided into 1 and 15. Whoops. 2 doesn't work. 3 and 5. Sorry about this 5. 4 does not work. And then I get back to 5, I'm done. The greatest common factor that the 12 and the 15 share is a 3, right? 1's too low. There's no 15. There's no 4 or 6 shared. So 3 is my GCF between these two, for the coefficients at least. So what we're going to say is the GCF for the coefficients, we just figured out really quick, was 3. And then we're looking for the GCF between the variables, which really you're just finding the common variable with the smallest exponent. So they both share an x variable. The one with the smallest exponent is this x squared. I'm cheating the system here. Ha ha ha. I'm going to put that there. No, what happened? Oh, that's so gross. Okay, sure. Okay. And then you just combine your coefficient part with your variable part. So I'm going to have 3x squared as my total GCF for these two terms. When we factor, so that was example 3. Wait, what? Oh, example 1. Yeah. Okay, let's keep going. Example 4 says when we factor a polynomial, the GCF comes out of the terms, then we use parentheses to show what is left. So here we're doing the whole thing, right? It's not just two individual terms. We're actually looking at an expression and doing the full thing. So first of all, let's find the total GCF for these two terms. To find the GCF, again, we're following these steps. Start by finding the GCF of the coefficients. So for 4 and 2, the greatest thing that I'm allowed to divide out of a 4 and a 2 together is a 2. 4 can be divided by 2, and negative 2 can be divided by 2. So the GCF is going to start with a 2. And then I have to find the common variable with the smallest exponent again, right? The GCF of the variable parts of the two terms. I have an x cubed and an x squared, so a common variable is x. And the smallest exponent, one of these two, is going to be x squared. So I'm going to put x squared over there. Now what we need to do is divide that GCF in the two terms to see what remains. So here I'm going to pull out a piece of paper. Actually, I think I still have room on this paper over here. We've got 4x cubed minus 2x squared, and the GCF between the two was 2x squared. Okay, let's do this. And also I'm going to do this really quick. Okay, so here's the expression we were trying to factor. And we saw, all right, 4x cubed minus 2x squared. And we just found the GCF 2x squared by saying, what's the biggest number I can divide out of both of these coefficients? 2 is the biggest thing that I can divide out of both of them. What's the most amount of x's that I can divide out of both of these? And it's going to be an x squared. Because if I try to divide an x cubed, this first guy is cool with that. But the second guy, not so much. So I can only divide an x squared out of both of them. And I'm going to show you two ways to visualize it. So next what we do is you can just follow the steps and say, all right, I found my GCF. I'm going to divide it from both of my terms. So I'll do 4x cubed, divide out the GCF, 2x squared. And I'll also do negative, right? Don't forget that it's a minus 2x squared. Negative 2x squared, divide out the 2x squared. And we just keep going from there. 4 divide out the 2 is going to be 2. X cubed, divide away an x squared. 3 take away 2 is just going to be an x, right? When you're dividing like variables with exponents, you subtract the exponents. And again, that's because I have x times x times x, right? That's what x cubed is. Divide out x times x. That's what x squared is. These x's will cancel out. I'm just left with a single x here. That's why that rule works. Let's keep going. Negative 2 divided by positive 2 is going to be a negative 1. Anything on top of itself exactly the same, they're going to cancel out. And here we have the bit inside of the parentheses, the two parts. So let's come back over here. When I divided out the greatest common factor from the 4x cubed, I ended up with 2x. And when I divided out the GCF from the negative 2x squared, I just ended up with a negative 1. And so here's where here's what the final answer looks like. You got to take the GCF that you divided out first and throw that in front of the parentheses. And then inside the parentheses, you put the two remaining parts of the terms after you do the division. So 2x minus, hold on, is this still in the exponent right here? What the heck? What's going on here? All right, I'm going to get in the parentheses over here, back on the ground. Boom, boom. Okay. 2x minus 1. This is what your answer looks like. And I want to, all right, let's double check to make sure this works. You check your answer by using the distributive property to make sure you get back with what you started. If I do 2x squared times 2x, 2 times 2 is going to get me 4. X squared times x is going to get me x to the power of 3. Ew. X to the power of 3. And then I do the second part. 2 times negative 1 is going to be minus 2. And then x squared times, there's nothing, it just comes along for the ride. X squared. And we'll make this look better. Shoot. Okay. This is showing that we got the right answer because when we distribute back, we got to what we started with. I like thinking of this in a different way. Following these steps will work, but here's how I like to do it. And I'll just show you that before we move on to more just practice problems. Okay. I'm going to rewrite the original question. So 4x cubed minus 2x squared. Let's jump to it. So here's what I like to think of. I like to literally do the opposite of distribution. So I figure out the GCF and I'm thinking, all right, what can I divide both of these by, right? I do know that, and here's how I'll do it. I look at the coefficients and I say, all right, what can I divide both of these coefficients by? And I know that 4 can be divided by 1, 2, and 4, and 2 can only be divided by 1 and 2. So the biggest number I can divide out of both of these is a 2. So I'm going to bring a 2 out front. Then I look at the variable parts and I say, well, what's the biggest amount that I can divide out of each of these? This is an x cubed, that's an x squared. I can divide an x squared away. So I'm going to be dragging out an x squared from both of these. And the reason I like to do this is because this reminds me of the opposite of distribution. Instead of having a number and doing my arrows for distributing, I'm using those same arrows but backwards to factor, which is really the opposite of distribution. And so now I'm going to put the parentheses and I just look at each of these and I do the division like we did up over here, right? I just like this way a little more visually. We're doing the same thing. I'm going to look at, all right, 4x cubed. When I divide out this 2x squared, 4 divide out the 2 is going to be 2. When I do the x cubed divide out the x squared, it's an x cubed divided by an x squared. It's just going to be an x. And then I'll do, oh my gosh, the paper keeps sticking. 2x squared divide out a 2x squared. Anything divided by itself is just going to be a 1. And don't forget to bring that negative along for the ride. And this is how I like to do it. But I'm doing the same thing, it's just a little more visual. But you can see here how this looks like the opposite of distribution. Okay, we're going to get to the examples. You're going to try to answer these questions as we go, and I'm going to start real slow and go through it step at a time, and then just start speeding up as we go through these answers, because this video is getting long enough. But you have all the way till, you have till the end of the weekend to get this done. So, we're getting to it. We are now factoring the following. So I'm going to write out a couple of these so we can just get back on the paper and go from there. So A was 2A plus 2A squared. B is 3x squared plus 6x. C is c cubed, ooh, I like this one, minus c squared plus 2c. And D is 3x squared minus 6x plus 3. Okay, let's do it. Starting with A. I'm going to do my visual way for this one first, and then the second one we'll do like the taking steps. So let's start saying, all right, well, I know I'm going to drag out something from this guy and something from that guy. So I'm going to draw my arrows there. For the numbers, both of these, it's a 2 and a 2, I'm allowed to divide out a 2 from both of those, right? You're looking for the biggest thing that I can divide out from each of these. So I can divide out a 2. Between the variables here, I have an a just by itself here and an a squared. So the most that both of these guys can afford is is a, right? For the variables. So I can divide out an a here. So that's what I'm going to be dividing out, is a 2a from both of them. I'll set up my parentheses, and then we're going. 2a, divide the a away. So 2a divide another 2a away. Well, that'll totally cancel out, it's a whole, right? So really, my first term becomes a 1. 2a squared divide a 2a away. 2a squared divide a 2a away. And I end up with the 2's cancel. This a cancels with that squared. I'm just left with an a. There's a plus sign between them. We're done. That is our solution. And if you wanted to distribute, you could check to see if we did it right. And 2a times 1 is going to get me the 2a. 2a times a is, the 2 just comes, and a times a gets me the a squared. We're good. Let's do this by following the steps instead of my visual way. So first, I'm going to find the GCF for the numbers, right? So here's just another way you can do this. I'm going to find the GCF for the numbers. I know that for each of these, why am I using the mouse? For each of these, I can divide 3 can be divided by 3, and 6 can be divided by 3. So I know the number GCF is going to be 3. For these guys, I have an x squared and an x. I'm looking for the smallest exponent that's available between these two variables. So the smallest exponent is here. It's just x to the power of 1, or just x. So there's my GCF, and then I divide each of the terms out. 3x squared divided by 3x. Those cancel, the 3's cancel. The squared cancels with the x over there, so I'm just left with, right, because x squared take away x. Again, that is x times x divided by x. That's what I'm doing. That's the cancellation I'm doing when I cancel that square and the x. I'm left with just x in the first part of my answer. And then I'll do 6x divide away the 3x. 6 divided by 3 is going to get me 2. The x's cancel, so we're done there. And it's x plus 2. And then finally, you just got to finish up by tossing this 3x in front of the parentheses. And that is our factored version of this over here. And by the way, if they say, here's an expression, here's 2 terms, find the GCF between the two of them, it's just that first part. What can I divide out of both of these guys? If we did the distribution, you'd find out that it's A-okay. Let's move on to letter C as another example. So this one's a little bit different because there are 3 terms here, right? Instead of just 2. That's fine. You're doing the exact same thing. I'm going to do this one the way that I like, again, visually with that like anti-distribute. So I'm going to drag out as much as I can from each of these. What can all 3 of these afford to get rid of? So in terms of the coefficients, this has really a coefficient of 1, this is a coefficient of -1, and this has a coefficient of 2. So I can't divide a 2 out of these guys. So the biggest thing that I can divide out is it's just a 1. So, I can put a 1 there, or it's going to be a coefficient of 1, so it doesn't show. Looking at the variables, the thing that I can divide out of each of these is c to the power of 3, c squared, and just a c. So the most that all three of these guys can all afford is just a single c. So the only thing that I can drag out of each of these guys is just a c. And so we just do the division, right? If I do the c cubed divide out a c, it's going to be c cubed divide out that c. This is c to the power of 3 divide out a c to the power of an invisible 1 up there. It's going to become c squared. And again, you can see that visually, c times c times c. Divide out a c, that becomes c times c. That's where the c squared comes from. So I've got a c squared over there. Why did I put that in parentheses? C squared. A negative c squared, drag that c out. I'm just left with a negative c, right? C squared, take away one of the c's, you're left with a c. 2c divide the c away, right? 2c divide the c away. Those will cancel. You're just left with a 2. So the greatest common factor that I could divide out of each of these was c. When I factor that out, I'm left with c, in parentheses, c squared minus c plus 2. Let's keep going here. Why do I keep closing the pen after every time? Let's do this the other way, not the visual way. So I'm going to look for the GCF between these guys. Looking at the coefficients first, I have a 3, a -6, and a 3 over here. All these I can divide a 3 out of. So I'm going to put a 3 as my GCF part. And then I have an x squared and x and no variable. You might want to divide an x out of these guys, right? Because both of these can afford an x. But this last guy can't afford any variables. So you cannot divide an x out. The greatest thing that I can divide out of all three of these terms is just a 3. And so what I'm going to do now is just for each term, divide that GCF out to see what it looks like when I factor it. So 3x squared, divide out the 3. Those 3's will cancel. My first term is going to end up as x squared. -6, divide out that GCF, divide out the 3. -6 divided by 3 is going to be -2. The x just comes along for the ride. And then finally, I have a 3 divided by 3, right? The third term divided by the GCF. That cancels, but it doesn't, don't get into the habit of canceling that if you think that cancels to become a 0. 3 divided by 3 is really a 1. It's a positive 1, so don't lose that last term. And then finally, to get my answer is really I divided that 3 out of each of them, so I need to make sure that it stays there. We're not changing what the expression looks like. We are changing what the expression looks like. We're not actually changing its value, right? So I have to show that I'm dividing that 3 out of each of them by putting it out front. I'm doing the opposite of distribution. I grabbed a 3 out of each of these guys and tossed it in front of the parentheses here. And inside the parentheses, I have whatever's left that these guys did not share. This has been a pretty long video, but the thing is, I think we just need to get more practice on it, and there are more practice questions, so we're just going to keep trudging along, right? This is the only video for this week. You got till Sunday to get it done, even though the quarter officially ends on Friday. I'm giving you the time till then to get it done. So I think it's fair for this to be a little bit longer of a video. Let's get to it. Okay, this next part says solve the quadratic equations algebraically, and this means to find the x-intercepts, and you're going to use the factoring we just learned to do it. So literally, well, all right, let's start by factoring and then remembering back to lesson 8.1, which was now like a week ago or even longer. I'm going to write each of these out. So I'm going to say, all right, 2x squared minus 4x equals 0. M squared plus 6m equals 0. Ooh, okay. 3x squared equals 9x. And then -4k squared plus 16k. What are the other examples down over here? Okay, yeah, we'll breeze through those last ones. Okay, but we are going to go through these in detail. just to show you, here's like really what it's coming down to, right? We're factoring in order to find the x-intercepts to be able to do this algebraically. I wonder if I close these blinds, if that will go away, if the lighting will look a little better. I don't know. Who cares, right? Whatever. Let's get to it. So we're going to factor these the exact same way that we were doing before. So you're factoring them, and then we'll talk about what that means as the answer. So here, I've got 2x squared take minus 4x. And so what we're going to do is I'm going to do it my visual way now. This is how I like to do it more. I'm going to divide something out from each of these. A 2 and a negative 4, I know that both of those can be divided by 2. An x squared and an x, I know that I can divide an x out of each of those. I'll do the parentheses, and now we're just going to look at each term and put them in their place. 2x squared, divide out the 2x. I pulled the 2 away, I pulled an x away. All that's left over here is just an x. Negative 4x, divide out a 2x. Negative 4, divide the 2 away. I'm left with negative 4 divided by 2 is negative 2. The x, I divide an x out. There's nothing left. This is our answer if we were just trying to get it factored. But now we want to know the solutions to the quadratic, where the x-intercepts are. And so here's what we've got. Once we have this, I need to figure out what can I make x equal to so that the equation makes it 0, right? So I see an x minus 2. If I said x equals 2 here, that would mean I'd plug in a 2 over here. 2 times 2 is 4. 2 minus 2 becomes 0. That part would be 0. X equals 2 is one of my answers. And then if I ever have x multiplying times things outside of the parentheses as its own kind of thing, I always know that x could also be 0. Because if I make this is 0 over here, 2 times 0 is 0. 0 times whatever happens in the parentheses is going to be 0. That will work. So the solutions over here are going to be x equals 2 or x equals 0. Yeah, I mean, you know, I can plug each of these in if you want to see, just so we can see the full thing, right? So we said that the solutions were x equals 2 and x equals 0. If I plug in one time as x equals 2, we'll do this. So I'll do 2 parentheses 2. And then in a smaller parentheses here, minus 2. 2 times 2 is 4. 2 minus 2 is 0. 4 times 0 is 0. And that checks out, right? If I try this one now, x equals 0, we're going to do, all right, 2 parentheses 0. And then smaller parentheses 0 minus 2 equals 0. 2 times 0 is 0. The 0 take away 2 is negative 2. 0 times negative 2 is 0 equals 0. That checks out. That's where the two solutions come from. So once you have this factored form, you look to see the opposite of the sign there. That's going to be one of your solutions. If you have an x multiplying times things outside of the parentheses, your other solution is going to be 0. Yeah, so we're factoring in order to find these two solutions over here. Let's see more examples of it, just to keep moving through it. Okay, m squared and 6m. So to factor and to find the solutions, I'm going to try dividing out from each of these, right? Doing my factoring, the opposite of distribution. An m squared and a 6m, there's no number here, so the biggest thing I could divide out is a 1. I have an m squared and m here, so what I can divide out of both of these guys can both afford just an m. And then we'll start doing it. M squared, divide the m out. What's left over here? M squared, divide the m out. It's just going to be an m. The 6m, divide an m out. 6m, divide an m out. Those cancel. I'm just left with a positive 6. This is my factored form. To find the solutions, I got to start saying, okay, I know that in here in the parentheses, Mr. Adler just said, I need to do the opposite of the number here. That will be one of my solutions. So one of my solutions is going to be m equals negative 6. And then the other one is if I have an m or a variable outside of my exponents, outside of my parentheses, then I know the other solution is going to be 0, m equals 0. This will be the last one that we check just for sake of time, because I know this video is already way over time, and I apologize for that. So let's check it, right? And I'm going to have to rewrite these other ones because I'm taking up all the space on the bottom over here. So we've got m plus 6. If I try, and we know the answers are m equals 0, m equals negative 6. If I try plugging in m equals 0, I'm going to have a 0 here. I'm going to have a 0 here, plus 6 equals 0. 0 plus 6 is just 6, but then the 0 times 6 makes 0, which makes it our solution, right? And that way we know that it works. If we try now the negative 6, we're going to say, all right, well, I'm going to put a negative 6 here in parentheses. Inside of the other parentheses here, right? We're bringing this down here, but plugging in a negative 6. Negative 6 plus 6, and to see if it works, it should be equal to 0. I won't distribute here, because I can just say, well, negative 6 plus 6 is going to be 0, and then 0 times negative 6 is going to make 0, and we end up with 0 equals 0. That shows that it's a solution. Let's finish up this video. Come on, let's go. Sorry that this is taking so long. I got to get the questions back. 3x squared. Oh, yeah, we definitely need to be going over this one, though. What am I doing? Bada boom. 3x squared equals 9. 3x squared equals 9x. Now, this one, and I'll just copy the other one. Negative 4k squared plus 16k equals 0. This example over here is definitely a weird one because it's not equal to 0. So we got to be really careful here. To be able to factor this, I want to make everything equal to 0. My whole expression should be all of my stuff on one side and then 0 on the other side to be able to factor out to find the solution to a quadratic. So you got to ask yourself, how can I fix this to make it equal to 0? And you got to use your properties of inequality. So what I'm going to do is, all right, I can just move this the 9x over by saying I'm going to do minus 9x to both sides. I'm allowed to do that. As long as I do the same thing to both sides, it's all okay. That will cancel out, goes away. 9x minus 9x becomes 0. And then 3x squared minus 9x, they're not like terms. So it's just going to come along for the ride. Don't lose the 3x squared. That became 0. Now it looks good. Now we're ready to factor over here. I'm going to start doing my factoring, opposite of distribution. What can I divide out of each of these guys? For the numbers, 3 and 9, I can divide a 3 out of each of those. For the variables, x squared and x, I can only take an x away. And then in the parentheses here, 3x squared, divide out the 3x, is going to be the 3's go away, the x's, I take away 1, I'm still left with an x. Negative 9x, divide out a 3x, is going to be 9. Negative 9 divided by 3 is negative 3. X, divide the x away. That's it. We're done with it. So here is my factored form, but now we want the solutions. Well, I know, right? This is our third time doing it. I look at the number in the parentheses. It's going to be the opposite of that number. So my solution will be x equals 3. If I have a number out front, that means it's going to be 0. Oh, I already said it. X equals 0 because I have a number out front here. If I multiply a 0, this x 0 times 3 and then 0 times that, it'll 0 out. So that's good. And then I have to do the opposite of the sign there. X equals 3. Those are my solutions for the quadratic. Let's finish this video up. Okay. What can I divide out of each of these guys? I'm zooming through because I know this video is already like 20 minutes. Boom, 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 boom. Let's do it. A negative 4 and a 16, I can divide a negative 4 out of each of those, or a positive 4, whatever you like. I'm going to divide out actually the positive 4. Why make it more complicated than it needs to be? So I divided out a positive 4, and each of these have a k, so I can divide a k out. Let's put parentheses here. Negative 4 divided by 4k. Negative 4k squared divided by positive 4k is going to be a negative 1k or just a negative k because negative 1k is negative k is the same thing, you know. And then 16k divided by 4k, the k's will cancel. I took a k away, so there's no k's left over here. 16 divided by 4 is going to be 4. Ooh, okay, well, this is where I done goofed, because you might think, oh, the opposite of that sign there, but I have a negative k here. You really want the variable in there to be positive, and then you can do that opposite sign. So maybe I should have divided that negative 4 out. I mean, you can still see it right. I have a k out front. K equals 0 is going to be one of my answers. But here you have to think a little bit because I didn't divide by negative 4. If I have a negative k plus 4, the thing that would make this term, this parentheses 0 out, is if k was 4, that would make this part negative 4 and then plus 4. Negative 4 plus 4 would be 0. It would be good. Let me just do this one more time by dividing out the negative 4, just so you can see like it'll look nicer than what we had here. So I'm going to redo it. Negative 4k squared plus 16k equals 0. Okay, I'm going to divide out a negative 4k this time, just so we get a nicer looking answer at the end. Divide out a negative 4k. Negative 4 divided by negative 4, it just becomes a positive 1. K squared divided by k, we're left with a k. This will become 16k divided about negative 4k. So the k's will cancel. 16 divided by negative 4 is negative 4. And now we see it a little bit better, more like the previous examples. So we see again, I have a k out front. K equals 0 is my answer. And k equals 4 will be my other answer. Last note, just to end the video, I'm sorry this took so long. Please come to office hours if you want to see more examples of this live. Here, for each of these two examples, I can't divide anything out, right? 2x plus 5, there's no number to divide out. This guy doesn't have a variable, so I can't divide a variable out. It's considered prime. There's nothing to be done here. I cannot factor this any further. Similarly here, I have an x squared and an x and no variable, so I can't pull a variable out of this expression. And 3, negative 4, and 7, the biggest number that divides out of all of those is 1. So I can't do any factoring. I can't anti-distribute anything here. So we're done. It's prime. Please, if this was confusing because it was a long video, send an email for some help. Come to the office hours. Because this is like, this is an important skill, and yeah, if you were turned off by it, try and take a break, maybe come back to it again later, because I could see how, if you're just trying to trudge through this video, it was a lot. Okay, there it is.